Good evening, my cherished viewers. I bring to you problem series sponsored by Master Scholars Academy and a Tesla One production. Now, I want us to go straight to the question or to the problem of the day for today. This is a problem in physics, and we are asked to determine the density of blood. And per the question, in order to determine its density, for those of you who cannot see from the other end, in order to determine its density, drops of blood is placed in the mixture of xylene of density 0.867 gram per cubic centimeter and bromobenzene of density 1.497 gram per cubic centimeter, the mixture being altered until the drops of blood do not rise or sink. The mixture then contains 72% and 28% of xylene and bromobenzene by volume respectively. And again, we have to calculate the density of blood. Now, this is our solution. Before you begin, you have to list the necessary parameters you can obtain from the question. That is 1, the density of xylene, 2, the density of bromobenzene, that is rho X and rho B. And also we have the percentage volume of xylene given to you as 72%. And also the percentage volume of bromobenzene, as you can see, 28%. Now the idea or the logic used to solve, or we are going to use to solve this question, is very simple. It's that if from the question, as we can see, that there was a continuous alteration, as to the proportion by volume of bromobenzene and xylene which was being added together, and it was realized that at a certain point, when 72% volume of xylene and 28% volume of bromobenzene were present, the blood wouldn't rise nor sink, which means that at this particular point, if the blood is not rising nor sinking, then it means that the density of blood is equal to the density of mixture, which simply means once we are able to obtain the density of the mixture, we are also able to obtain the density of blood. So the most important thing is to calculate for the density of the mixture, and having that, we can get the density of the blood. So one thing I want you to also look here, it's very worth noting that you can see 72 cubic centimeter here, and you see 72% over here. Over here, you see 28 cubic centimeter here, and you see 28% over here. Now, it's quite interesting to note that if we have 72% and 28%, we are dealing in percentages. When you sum up these percentages, it equals to 100, which means that the total volume of the mixture can be equated or is equivalent to 100 cubic centimeter. If that is the case, then it means that the volume of xylene, which is 70%, is equivalent to 72%. As you can see here, it's very boldly written here. 72% is equivalent to 72 cubic centimeters, and the volume of bromobenzene, which is 28%, also equivalent to 28 cubic centimeters. So as we know, density is equal to mass over volume, or mass divided by volume. So if you have an expression mass divided by volume and you make m the subject, that is mass the subject, you get rho times v, that is density times v, gives you the mass. So from that formula we all know, I remember from class I explained all these things to you. I will expect you to remember. Now, so if you have the density of xylene given to you as this and its volume, you multiply and you get 62.424 grams as you have here. You go on with the same approach. You multiply the density of bromobenzene and the volume of bromobenzene to get what? The mass of bromobenzene. However, pardon me, this side is supposed to be rho B, not X. X is for xylene, but this is supposed to be rho B, and also volume of B. So density of bromobenzene multiplied by volume of bromobenzene, and that gives you the mass of bromobenzene, as you can see here. Now, after getting the masses, you need the total mass of the mixture, or the mass of mixture, to obtain the density of mixture. Because to obtain the density of mixture, you need the mass of mixture over volume of mixture. Now, the mixture is made up of bromobenzene and xylene. And so to get the mass of mixture, you sum up the mass of bromobenzene and the mass of xylene. And as you can see here, we have 104.34 grams. We go on to determine the density of mixture, and we divide the mass of mixture by the volume of mixture. Okay, so we divide the mass of mixture by the volume of mixture. The volume of mixture is obtained by summing up the volume of xylene and the volume of bromobenzene, and that gives us a total, in fact, the density of mixture to be 1.043 grams per cubic centimeter. As simple as possible. Just as we said that the density of mixture will be equal to the density of blood, because there was a clue in the question that at that point where we had that proportion by volume of bromobenzene and that of xylene, the blood neither rise nor sink. In that case, density of mixture is equal to density of blood. So to obtain the density of blood, we are saying that is the same as what? 1.043 gram per cubic centimeters. Thank you very much for watching, and please note that this is a Tesla One production and sponsored by Master Scholars Academy.